Hi, welcome to Data Leader Show. I have Zach with us today. I'm very excited to have him on the show. Welcome to the show, Zach.
Thanks, all. Excited to be here.
Yeah, we are very happy to have you on the show. For the past 2 years, Zach has been working as a data scientist in an industry-leading data science consulting firm, and you're a recent graduate of UC Berkeley's data science program, and that's where I met you. So I am very glad to have you on the show here. One of the things I learned about you, Zach, is that not only are you a super smart, super genius data scientist, but you also have worked as a teacher of
hmm
math and physics, and that gives you the ability to communicate so well and talk and boil things down in a way that people like me can understand it. So very happy to have you here on the show. And can you tell me to start things off? I'm going to keep this very lean. Can you tell me to start things off some of the most exciting data science projects that you've worked on in the last few years? Also, I forgot to mention one of the things about you to our audience is that you have background in fraud analytics, and you and your team has worked together to save hundreds of millions of dollars of federal money using your sophisticated data science techniques. So I can't wait to hear about that. But this is more about something that you're excited about. So tell me something that you've done that that really excited you in the data science space.
Yeah, I think the most exciting project that I've worked on, and worked on it with a team, was the project that you heard me and my team present on at the UC Berkeley Data Dialogues Conference a couple months back. And that project was really centered around answering the question, can we predict what pitch is going to be thrown next in Major League Baseball? And it's a really interesting and tough question. I think everyone's kind of brought up in data science and they hear the canonical example of Moneyball, of, this out-of-game analytics, picking the best players to create an optimal roster that's going to score a lot of runs on a budget. And so essentially what we tried to do was to say, okay, this is analytics like in batch outside of the game. Can we push analytics inside the game and within a 20-second window predict what pitch is going to be thrown next by an MLB pitcher? So they're going to throw a fastball, a curveball, sinker, slider. And not only that, but could we do it in a time frame such that with this goal of someone's in the dugout with an iPad, the pitcher throws a pitch, all the model knows all the information about the game, what the pitcher's done in the past, etc. We run all of that information through our model and we get a prediction. If it's a high enough probability that, say, it's going to be a fastball, then can someone in the dugout signal out to the third base coach who signals to the batter and tells the batter this pitch is really likely to come next. Sit back on that pitch and drive it. And so it's a really cool concept. And so our project was really to proof out, is this possible? And the short answer to that question is yes, we think it is. And not only is it possible, it's probable that we're going to see this in Major League Baseball in the future. And I'll tell you why. Is because baseball has made a recent commitment to allowing technology in the dugout. So they're trying to push analytics more in game. They're going to allow iPads in the dugouts next year. And this kind of in-game modeling, I think, is really about to take off, where we're going to see the Moneyball of in-game analytics. And it's going to be really exciting. Um,
Yeah. That's pretty awesome, dude. Moneyball of in-game analytics. I love it. I love it. It's gonna eat the static analytics for lunch or for breakfast, I guess. So
exactly.
that's gonna change the entire industry. What? Don't let me interrupt you if you're gonna talk more about the project, but I definitely want to touch on some of the things that you talked about the success rate and the superstition, et cetera, as well as the ethics. Are you going to take the joy out of the sport away by predicting every single pitch? But
Yeah.
you can talk about that later. But definitely want to let you talk a little more about more in game analytics stuff.
Sure. So maybe I'll just detail quickly exactly what we did and get quickly to the results, which is what everyone cares about. So what our system does that we built is it's really hundreds of machine learning models. And, when we started this project, we knew this was a real need in the game because we actually saw this very famous quote by Hank Aaron, who's the second all-time home run leader in Major League Baseball. And his quote goes something like, 80% of being a successful hitter is knowing what the pitcher is going to throw next. The other 20% is just execution. And so what these players do is that they're watching tons of game tape. They're studying the patterns of the pitcher. They're seeing what the pitcher did to them in the past. And they're trying to synthesize basically all of these variables. In this situation, what does the pitcher do? What has he done with me in the past? And they're trying to put all these variables together in their head and get an intuition of what's coming next. Now, as humans, we're good at keeping track of a few variables at once, but computers are great at keeping track of all the interactions of tons of variables. So seeing this problem, we're like, this is a perfect machine learning problem. We've got like tens or hundreds of variables that we can use in order to predict what's coming next and actually help a hitter out. So what we do is that Major League Baseball provides pitch level data for every single game going back to 2008 on their game day servers. And so we wrote some scripts in Python to go up and to pull all of that XML data down to create the features that we thought were interesting. And then for every single pitcher, we are creating these machine learning models and validating them for about 500 or 600 pitchers in Major League Baseball. We're storing and keeping track of all of these models once we know that they're statistically sound. And then when it comes game time for a real live game, what our system does is it goes and grabs the model that we've built offline, and then we point it to the live game day server, so it pulls the data in near real time, and then we have a Twitter bot that's tweeting out the predictions of what we think is coming next. And so that was kind of the prototype to say, like, we're like near real time doing this. Can it be done? And can we get it out there on Twitter so that we can be transparent about our results of how well we're doing? And so that's the system. And the bottom line of the results is that, can we predict these pitches that are coming next? On average, yes. We're about like 5 to 10% more accurate than just guessing the most common pitch. But the interesting thing when you look at that accuracy across all the pitchers is really the standard deviation of that. So for some pitchers, we are really, really accurate, and they are pretty predictable, and it would be really useful to use these models. For others, given the feature set that we chose, it's actually pretty difficult for us to predict what's coming next. And even more interesting than that is we're thinking, well, are the better pitchers in baseball, are they the ones that are tougher to predict, or are they just as easy to predict as others? And there's actually no correlation between the predictability of the pitcher and their ERA, or earned runs average, which is a metric to gauge how well a pitcher is doing in a season. And so, and so that's the results. With some pitchers, we're 80% accurate over all the pitches. But more interesting than that is when we make a prediction, can we be certain of the probability of that prediction? Because we don't want to tell the batter every single pitch what we think it's going to be. We only want to tell the batter when we're really sure. So are we able to be 80 to 90% sure 30% of the time or 50% of the time? That's actually the interesting metric, because we want to give the batter only the most certain ones so that they can be very sure of what's coming next, so that it engenders confidence in our analytics and our models. So that's the results. We are pretty accurate across a lot of pitchers and really, really accurate on about 20% of the pitchers.
Wow, 80%, 80%, that's a major, that's a major influence. That's a major prediction there. So what did you learn after the end of this project? What was your biggest learning lesson, Zach?
Yeah, I think one of the biggest things that we learned is that, I alluded to this a little bit earlier, but, when you're going through and you're learning how to validate models, and like doing machine learning, you get a sense like, okay, you establish your baseline. If I were to guess the most common class or the most common pitch every time, what would my accuracy be? And then what is the model doing? How far above that baseline is the model? But really what we learned is that the domain should really dictate what your outcome metrics are. So just instead of saying we're 75% accurate across all pitches compared to a 55% baseline, it's actually more meaningful in this context to say we can be 80 to 90% sure of what's coming next 30% of the time. So it's actually more interesting to us to define the metric that makes sense to the people and the users that are actually going to be consuming the model. And that's really just letting your domain dictate what your outcome metric is. And it makes a lot of intuitive sense, but you have to kind of stray away from what you're like kind of more rigidly taught in like a machine learning or statistical learning class.
Mm. Yeah, one of the things that we learned from the same conference was some chief data officer was present there. I think it was Wells Fargo's guy, and they mentioned that number one thing as a data science team you can do is to gain trust of the people that work in your organization, and to your point, gaining trust of the batters by telling
Exactly.
them 20% of the times how accurate you're going to be is so much better than saying 80% of the times communicating the low accuracy results. So
Yep.
that it's funny how it plays out even in the algorithms along with the people. So
Yeah,
uh,
exactly.
yeah. Well, Zach, you're a superstar in this space now. Now that you've figured out how to predict the pitch, and now you're going to be multi-millionaire in no time. Just, but what's next? What's next for you, man? What's now that you're done with the program? You're obviously put a lot of things on hold for in your life to get through this program. It was a very challenging program. So what's next? What's next in the chapter of Zach?
Yeah. Well, we were discussing this a little bit earlier, but I was talking about how going through the program and working makes you have really awesome time management skills. So I don't really want to lose that. I kind of want to just shift my focus to professionally to some cool data projects that have been out there that are doing a lot of social good, where people are now volunteering their skills and skill sets as software engineers or data scientists to perform these projects where there's these nonprofit organizations that by their nature cannot necessarily afford to pay people for these kinds of skills. And so a couple of those projects, one of my coworkers now is working with an organization called DataKind. And one of the things I'd love to do is get involved with them in some of the projects that they're doing. They're working with organizations like the Red Cross and and a number of other nonprofits to really do some cool like emergency planning situations, like using data science, like how to better inform policy around emergency planning. And then my other friend sent me a link to this website or this organization called Thorn. It's actually sponsored and co-founded by Ashton Kutcher, and it's a call to end sexual exploitation of children. They're just kind of amassing this army of data scientists and software engineers to track down, because the primary marketplace for all of this is the internet. And so they're calling on data scientists and software engineers to track down where this activity is occurring and who's performing it, and then, use analytics to kind of inform police officers where to investigate and to shut those kind of activities down. So I recently signed up with them and hope to be hearing back about maybe getting started on a project there, which would be pretty awesome.
Wow, that's exciting, man. Lot of different things online for you here. So making some nonprofit contributions as well as getting involved in the data kind projects. That's pretty interesting. So one of the things that really strikes me here is that your presence of mind when you're talking about data and communicating your findings. Can you add a little bit color to that? What's your process like? How do you gain that in your day-to-day life as a data scientist?
Yeah, that's a great question. And I think it starts with what first intrigued me about data science. I've met some people that are just very intrigued by the algorithms and just getting to solve puzzles and problems all day. But my attraction to data science was actually seeing it as a means to affect change. And so at a large scale from a single person. And that's what intrigued me about it. So it wasn't necessarily like looking at the technique and saying, wow, cool algorithm. It was looking at the potential impact, like when we talk about being able to recoup lots of money for taxpayers or being able to predict a pitch. There's some real world problem that data science can speak to. And so I always like think about and try to frame the problems in terms of a real world scenario and situation. And when you do that, I think it helps you to explain your findings and what you're trying to do in more like natural language to somebody. But you always got to have those details to back them up. But I don't know. So I guess it means I like to think of the end and then let the technique speak to the end rather than thinking, oh, I'd really like to use technique X or Y, and then I'll find a problem for it.
Right. Putting the cart before the horse, as some would say.
Exactly.
Yeah. Hey, going back to your primary project here and my earlier joke about multimillionaire, what is the economic impact of being able to do something like predicting a pitch more accurately in terms of a game, its economic impact, and dollar significance, if you may. Can you add some color to that as well?
Yeah, I can speak a little bit to that. We've done more kind of back of the envelope calculations in terms of dollar amount and impact, and so building a model such as these, if you know what pitch is coming, naturally leads to more hits, which more hits leads to more runs, leads to more wins. And even just minor, like when people have done simulations on this kind of thing, even just a few, like a couple more hits a game, can translate into a lot of wins over a season. And so the impact in terms of a hitter using this, what is a hitter's value? A lot of sabermetrics and boils down all of this to a statistic called wins above replacement. So if a player is in a lineup, how many more games is that team going to win as compared to his backup being in? And what we project is that for a single hitter, you would be able to get a few more wins above replacement using these models. And so one win above replacement in Major League Baseball today is valued at about $5 to $6 million in a yearly contract for a player. We project for every hitter like a few wins above replacement, and each of those is valued at $5 to $6 million.
Wow, that's going to change the game for real. Yeah.
Has the potential to.
Yeah, has the potential to. Spoken like a true data scientist.
Yeah.
All right, so next here, I wanted to chat with you about how do people get in touch with you? Obviously, you're a busy guy, and I don't know how open you are to consulting projects and whatnot, but it was just a struggle to get you on this podcast because we've been talking about it for months, and finally I was able to get some of your time here to have you show up on the podcast. But how do people get in touch with you if they choose to get your advice and consult you?
Yeah, I love to talk to people. Sometimes it is tough to carve out a little bit of time. If anyone would love to contact me about this kind of work, or even like if you heard something I said or think I would be helpful on a project that has some real impact, then I would love to chat. The best way is by email. My email is zbeaver, just like the animal, zbeaver4@gmail.com, or just look me up on LinkedIn, Zachary Beaver, and there's not many of us out there, not many beavers.
Great, man. Hey, thanks for sharing your information. I'm very sure that people will be excited to get in touch with you, especially after this show here. And best of luck with your data science pursuits, especially the nonprofit ones that you're talking about, Torn and the Red Cross and whatnot. So very much of good luck for those pursuits. And when you're ready for an update with your current project or any other exciting projects that you think the data science community should be aware of, I'll be very happy to get you back on this podcast, and we can talk more about it. In the meantime, let's stay in touch.
Awesome. Yeah, thanks so much for having me on, Deval. This was awesome.
Yeah, it was pleasure learning from you and hearing about all the cool stuff that you're up to. Thank you, Zach.
All right, thank you.